We've talked about how much energy is required to melt snow, but we haven't really talked about where that energy comes from. And that is the focus of this video. So let's draw a picture. Here we'll have the ground surface, and then we'll have some snowpack. We may have a tree that's rooted into the ground here. And we'd now like to depict the net fluxes of energy into the snow. All of the ways that heat can be added to the snow from the environment to cause melting. From the subsurface, there's really only one input flux, and that's conduction from the ground itself. So in general, the ground is warmer than the overlying air in the winter, and so this is a source of heat flowing from high temperature to low temperature. Okay. We know, of course, when it's sunny out, we can get solar radiation, and this is a form of shortwave radiation that's coming in and can hit the surface of the snow and cause it to warm up. There's also a couple different sources of long wave radiation. So this is a longer wavelength. It's also radiant energy. It could be coming from clouds. It may also be coming off of the vegetation that's over the snowpack itself. So this is another way that you can get long wave radiation. Another key source of energy is the flux or the transfer of latent and sensible heat. And I'm going to depict this one kind of as a squiggly line because it's typically a turbulent transfer. So this is a latent and sensible heat transfer. And so you can think about maybe, for example, warm air blowing over the surface of the snow, causing it to warm up. Finally, there's one other source that we should consider, and that is, imagine that it's springtime and it's raining. So these are supposed to be raindrops here coming in. So this would be advected heat. If it rains and that rain is very warm, it's going to bring that warmth down into the snowpack. At different times of the year, different sources of energy are more important. Shortwave radiation is an important one. Latent and sensible heat transfer is another key one. And then in the Pacific Northwest, the advection of warm water into the snowpack in the form of rain can also be a particularly important source of heat to melt the snow.